Hello everyone, welcome back to this online class. Today I want us to look at homogeneous ODEs of the first order in three variables. We are given the Pfaffian differential equation that y squared plus yz dx plus z squared plus xz dy plus y squared minus xy dz is equals to 0. So we are asked to find the general solution. Now, for us to be able to solve this, remember, there are 5 methods of solving Pfaffian differential equations. The first one is when you have all the variables separable, you simply integrate directly to get the general solution. Another method, when you have one variable separable, there's a way to solve that. Another one is regrouping. Another method is homogeneous method, where you make certain substitution. And the last method is the Natani's method. So when you look at this equation, it is homogeneous of degree 2. Let us solve it as homogeneous ODE. So these are the substitutions you're going to make. So you say let y be equal to ux and z be equal to v times x, where u and v are functions of x. So with this substitution, we also need to know the corresponding differentials. When you differentiate y using product rule, you keep u constant to differentiate x, plus, and now keep x constant to differentiate u. Similarly, derivative of z, product rule again, keep v constant to differentiate x, plus keep x constant, differentiate v. So we make this substitution into the given ODE. Now let's substitute. Our ODE will now be this. If we substitute y squared, that is the same as u squared x squared, then plus y times z, that is uv x squared, with the coefficient of dx, plus z squared is v squared x squared, plus x times z, that is x squared v. dy is u dx plus x du. The third term, we have y squared, which is u squared x squared, minus xy, that will give us x squared u, dz, we said that is a v dx, plus x dv. And this should give us 0. This equation, if you look at it, you realize that x squared is common. So this equation can as well be written as x squared outside into u squared plus uv dx, another x squared outside here into v squared plus v. Again multiplying u dx plus x du. Another x squared outside into u squared minus u multiplying v dx plus x dv to give us 0. X squared is common. This will cancel with this one and with the other one. Or simply you divide the entire equation by x squared. So having divided that by x squared is what you're going to get, or u squared plus uv dx plus v squared plus v times u dx plus x du. plus u squared minus u times v dx plus x dv. This should be able to give us 0. And so I can now collect the like terms. You see the dx, you can see dx appear here. One, the other one is here, and another one is here. So it appears 3 times. Let me combine those dx to form one term. So this can be written as u squared plus uv, that's the first term. Then this other one, I'm multiplying by u, so plus uv squared plus uv. The third term I'm multiplying by v, so plus u squared v minus uv. The whole of this is the coefficient of dx. The coefficient of du will have plus x times v squared plus v du. And the coefficient of dv will have plus another x into u squared minus u dv. That should give us 0. And I can now simplify this expression or this equation. Look at the first term. That can be factorized. If I factorize the first term, this is what I'm going to get. I can see u squared and another u squared, factor out u squared, so that we have 1 plus v. Then plus, of course, the uv will cancel with this other uv. So I remain with this other two, this and this one. Again, uv is common into 1 plus v. So 1 plus v is common. So 1 plus v common into u squared plus uv. And in the second bracket, u is common. So this can be written as 1 plus v times u plus v. So that's the coefficient of dx. So this can now be written as, our equation can be written as u into u plus v into 1 plus v dx plus, you see x is common, so x outside, v squared plus v du plus u squared minus u dv. This is supposed to be equal to 0. This one is a separable ODE. Let us separate the variables. We are going to get dx over x plus, of course, this is the same as v into v plus 1. Remember, v squared plus v. Then we are dividing this by u plus v, 1 plus v. This is du. Then plus the other one. Here I can see u is common, so I can write this as u into u minus 1. All of this divided by u into u plus v into 1 plus v dv is equals to 0. And so we can now simplify this last two terms. You see, v plus 1 will cancel with v plus 1. The u will cancel with u. So this thing can be written as, or dx over x plus v over u into u plus v du plus u minus 1 over u plus v times 1 plus v dv. That should be equal to 0. So I can bracket this equation. This is the one we need to integrate to get our general solution. But you see, we cannot integrate the way it is. Of course, the first term is easy to integrate, but what about the second and the third terms? It's not easy to integrate those two terms unless we decompose them. If you look at the denominators in the second term and the third term, you realize that we have a product of two linear factors in the denominator, and every time you're integrating where you in the denominator you have a product of maybe linear factors or quadratic factors, then you need to think of partial fraction decomposition. So even before I integrate this equation, let me call it equation star. Let me decompose the second term and the third term using partial fractions. So second term, we are going to say let v over u into u plus v be equal to a over u plus b over u plus. And I told you when the denominator is a linear factor, the numerator must be a constant. That's why we have a over u, because u is linear. Then the other one is b over u plus v. U plus v is linear, so numerator must be a constant. So our task is to find the values of a and b. They are the constants. So when I multiply this by the LCM, I'm going to get a times u plus v, then plus b times u should give us v. In this equation, if I put, can pick a different color. Let me use green. If I put, let's say if I put u is equals to 0, what will I have? The term in b will disappear, so that the term in a will just be a times v is equals to v. So that will give us a is equals to 1. I also need to find b, so I can put u is equals to negative v. So the first term will vanish. What about the second term? Negative bv is equals to v. So when you divide, you get b is equals to negative 1. So we have found those constants. Now we can say that therefore v over u into u plus v can now be written as 1 over u minus 1 over u plus v. So that's what we'll write in place of the second term here. That's what we'll write. Let's also decompose the third term. Third term, let me write third term. You say let u minus 1 over u plus v. This is multiplying 1 plus v. Let this be equal to a over u plus v added to b over 1 plus v, of which if you multiply both sides by the LCM, let me use another color. If you multiply both sides by the LCM, we are going to get a times 1 plus v plus b times u plus v is equals to u minus 1. Again, this equation is true for whatever value of u and v that you choose. You can choose some values that will help us get those constants a and b. So if I put, you realize that if I put u is equals to negative v, what will I get in that equation? I'm going to get a into 1 plus v is equals to, because the second term will vanish. So on the right hand side, we'll have negative v minus 1, which is negative of v plus 1. So you're going to get a into 1 plus v is equals to negative of v plus 1. I've factored out the negative. So you see, when you make a the subject, you're going to get a is equals to negative 1. That's very clear. What about if I substitute, because now I need to find b. For me to get b, I can eliminate the first term, the term in a. So you can put v is equals to negative 1. You can say put v is equals to negative 1. That means the first term will vanish, will be 0. So that we now remain with b into u minus 1 is equals to u minus 1. That will give us b is equals to 1. So then it means that, therefore, that u minus 1 over u plus v into 1 plus v can now be written as negative 1, which was a, over u plus v, plus 1 over 1 plus v. Very important. So now let's go back to our equation. The equation we call star. Look at it. This one. So we make those substitutions. I now know the third term and the second term. So that equation star can now be written as, let me pick another color. So you can just say therefore, hence, or simply hence, equation star can now be written as dx over x plus 1 over u minus 1 over u plus v du plus 1 over 1 plus v minus 1 over u plus v dv is equals to 0. So that's what we have. And this thing can be written as, let me regroup it. You write or dx over x plus du over u, I'm opening the bracket, minus du over u plus v, then I can see plus dv over 1 plus v minus dv over u plus v is equals to 0. So look at this term and this one. We can combine them because the denominator is the same. So or dx over x plus du over u plus dv over 1 plus v minus du plus dv over u plus v. I've combined those terms, the ones that I have ticked. I have combined them into one term. Now, it's now easy to integrate. Let's now introduce the integrals, integrate each term, integrate this, 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 and this, and even the right hand side. On the left-hand side, we'll have natural log of x plus natural log of u plus natural log of 1 plus v minus natural log of u plus v should give us natural log of a constant c. Now, get rid of the logs, the natural logs. Use the laws of logarithms. Log a plus log b is equals to log of a times b. That's the first law. Another law, log a minus log b is equals to log of a divided by b. That is the second law. And the third law is m times log a is equals to log of a raised to m. So when I combine those laws, when I use the laws of logarithms, what are we going to get? So like on the left-hand side, we are going to get ln of xu, x times u times 1 plus v. When you're subtracting, you divide u plus v. That's what we have on the left is equals to ln c. When you take exponential on both sides, we are going to get x into u times 1 plus v over u plus v is equals to a constant c. I can also cross multiply this, or x times u times 1 plus v is equals to c into u plus v. This is our general solution where c is an arbitrary constant, but we have to replace u and v. Check where we defined u and check where we defined v. We said let y be equal to u times x, so make u the subject. That means u is equals to y over x. So we are going to say put u is equals to y over x. What about v? We said z is equals to v times x. So that means our v will be z over x. Let us substitute them here in this equation. This equation will now be written as x times u, which is y over x, 1 plus v, which is z over x, is equals to c into y over x plus z over x. That's what we have. And so we can simplify. You see here, x will cancel with this x. So what I have is, or you can see we have y outside into 1 plus z over x is equals to c into y plus z over x. If I multiply both sides by x, I'm going to get this, or xy into 1 plus z over x is equals to c into y plus z. The left-hand side, you can take x inside, or y outside, take that x inside, we'll have x plus z being equal to c y plus z. So this is our general solution. A C that we have here is an arbitrary constant. So that's how to solve a Pfaffian differential equation when the equation is homogeneous in three variables, x, y, and z. Thank you all for watching. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type there Prof. Francis Okech. You will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we look at other problems involving partial differential equations. Bye-bye.